All right, guys, here we are, Thursday, May 7th. Today we will be covering our very last lesson of new material for the year. So, congratulations on making it through a whole year of Algebra 1. Hopefully, we understood the information and we know a little more than we did before we got into this thing. But today we're going to cover lesson 11.7, okay? This will be our very last lesson of the year. And then after this point, we will begin our review for the final exam. And we'll take that bit by bit and cover some important information on that. Again, as I said before, the plan to take the final exam is on Wednesday. That will be Wednesday let me see here, 13th. Okay, so Wednesday the 13th will be your final exam for algebra, and we'll take Friday, Monday, Tuesday, and cover the information on there. So if there's anything you need re-explained, or you didn't understand something, or you see something on the test that you don't really know what it is, let me know, and we'll take some time and go over specific areas like that. Okay, but today let's look at 11.7, adding and subtracting with different denominators. Okay, we talked last lesson on the LCD, finding the LCD, and now we're going to apply finding the LCD to actually adding and subtracting these fractions. So before we were just finding the common denominator and then rewriting our fractions with the common denominator. Now we're going to apply that to actually adding and subtracting the fractions together. So we're going to take the steps from finding the LCD, and we're going to take the steps from adding and subtracting fractions, and we're going to combine them together in this lesson. So it's not really new material so much as just combining the two old lessons together. Okay, so we shouldn't have too much problems with this, but let's go ahead and look at this. I'm going to clear this off here. Actually, let's just leave this up. Okay, here are our 7 steps for adding and subtracting rational expressions. Okay, so if you'll notice, a lot of these are similar to finding the LCD, and then you've got adding and subtracting steps. So let's walk through here. Adding and subtracting rational expressions. The first thing we're going to do is we're going to factor each denominator. Now remember, when factoring each denominator, we're talking about, doesn't matter how many denominators that we have. We can have 2, we can have 4, we can have 3, whatever it may be, but you're going to take every single one of those denominators and you're going to factor them out, okay? So first step is to factor each denominator. Now remember, some denominators won't have any factoring to do, okay? But you'll just write them out as it is. So there will be some case, and we covered that last lesson in the LCD section, where there were some denominators that were already factored and there was nothing else we could do to them. After we factor, the second step is going to be to determine the LCD. Okay, and we talked about that. We take our denominators and we factor them out so that we can see every factor in there. And then we take each factor, and the greatest amount of times that it is present in any one term is how many times it will be present in our LCD, and everything must be represented there. Step number 3, we're going to rewrite the rational expression with the LCD. So just like we were doing before, you're going to multiply each fraction by what's missing, so that you create your new fractions with your least common denominator. Okay, now here's where the adding and subtracting steps come in. Step number 4, we're going to combine the numerators over the LCD. If you remember the adding and subtraction section, we took those numerators and we basically just added them all together on the top over one denominator, okay? Because all the denominators were the same, we could just combine all those numerators together, and this will be the case with adding and subtracting. But remember, with subtracting, we have to change the subtraction sign to addition, and then we can add them all together, and we'll see those steps as we go through here. Step number 5, just as before, we cancel our common factors. Step number 6, we take those canceled factors and we set them to 0, so that we can find our excluded values. And then step number 7, we write our answer with our excluded values. Okay, so these are the steps then for adding and subtracting rational expressions. Make sure you get these in your notes. Okay, we're looking at here lesson 11.7a. Okay, we are on page number 429. I don't know if I went over that or not, but you should have titled your notes lesson 11.7, adding and subtracting with different denominators, and then include these 7 steps in your notes. Okay, so let's look at some examples of how we're going to walk through these 7 steps of adding and subtracting rational expressions. Okay, so let's clear this out here. And we're going to start with the real basic one. We've got 2x over 15 plus x over 3 plus 3x over 5. Okay, so now first step is we're going to find our LCD. So we take our first denominator of 15 and we write our factors of 3 and 5. Then we have 3 and our only factor is 3, and 5 and our only factor of 5. So we take this to find our LCD. Oops, excuse me. Not LD, LCD. Okay, so the first one we have 3 and 5. Here 3 is already represented, 5 is already represented, so our LCD is 15. Okay, and then taking our LCD, we're going to take these fractions and rewrite them with our least common denominator. So we have 2x over 15. We already have our common denominator there, so we don't have to do anything to this fraction. So then we move on to the second one, over 3, and I look at my denominator. 3 is already there, but I'm missing 5, so I'm going to multiply by 5 over 5, which gives me 5x over 15. And then I take my 3x over 5 and do the same thing. 5 is present, but 3 is missing, so I go 3 over 3. So 3x times 3 is 9x over 15. Okay, so now I have my three new fractions. I'm going to rewrite them in the addition just like I have it up there. So I've got 2x over 15 plus 5x over 15 plus sign there, plus sign here, 9x over 15. Okay, so here are my new fractions over my common denominator. Okay, now we're going to combine everything over one denominator. So we can do this in 2 steps, or you can do it in 1. I can write this as 2x plus 5x plus 9x over 15. Or I can just jump right to this step where I combine them all together. 9 plus 5 plus 2 is 16x over 15. If you want to skip this step, that's fine. You can combine them all and jump right to this step. Or if you'd rather write them out so you can see all of them, make sure you're combining correctly, you can. So it's up to you if you want to just skip this step or not. So in this case, there was nothing to cancel out. So this then is my final answer, 16x over 15. Nothing was canceled, so I don't need to exclude any values or do any of that. Okay, so this is just a real basic form of this process. Let's look at something different now. Okay, let's look at 3 over x plus 1 plus 2 over x minus 3. Okay, so first my LCD. Okay, so x plus 1 equals x plus 1. And then x minus 3 equals x minus 3. So my LCD equals x plus 1 times x minus 3. Okay, excuse me. Now I'm going to rewrite using my common denominator here. I'm going to find what's missing. So what do I need to multiply this by? Well, that's obvious, x minus 3 over x minus 3. So that gives me 3 times x minus 3 over x plus 1 times x minus 3. Then I take my second fraction, 2 over x minus 3. I'm going to multiply by x plus 1 because that's what's missing in my denominator. So I've got 2 times x plus 1 over x plus 1 times x minus 3. Okay, now, typically before we just left this as our answer, but because we're actually adding and subtracting, okay, we're going to need to go ahead and FOIL these or multiply them out. But first, we're going to rewrite them in the form that we have them. So we've got 3 times x minus 3 over x plus 1 times x minus 3 plus 2 times x plus 1 over x plus 1 times x minus 3. Okay, so now we're going to take this and we're going to multiply here. So we're going to go 3 times x is 3x, and 3 times negative 3 is a negative 9. Okay, then we've got plus, because of this right here, and then 2 times x, which is 2x, and 2 times 1, which is 2. And this is all over our common denominator of x plus 1 and x minus 3. Okay, now, so we've got our common denominator. We've FOILed everything out. Now, what we need to do is we need to cancel our common factors. Okay, cancel our common factors. Hold on just a second, please. Okay, sorry about that. This is what happens when you teach with kids around. Okay, so where were we at? We combined we multiplied to combine everything over our common denominator. Our next step would be to cancel our common factors. Now, looking at this, we really don't have any common factors to cancel, okay? So then we would go ahead and combine our like terms. So we've got 3x and 2x. That gives us 5x. Then we've got a negative 9 and a positive 2, which gives us a negative 7, over our common denominator of x plus 1 and x minus 3. Okay, this would actually go before our canceling. I apologize about that, but same thing. There's no canceling to be done here, so we just combine over our common denominator. There's no values that have been excluded, and there's nothing else to be done, so this then would be my answer. Okay, pretty simple. In this case, nothing to cancel out, so there was nothing to exclude in our answer. All right, so here's another example here. Now let's look at one where we're actually going to have to do some canceling and including our excluded values. Okay, so let's start here at the top. We've got 10x plus 8 over x squared minus 1 plus x over x plus 1 plus 3 over x minus 1. Okay, so we take our first denominator of x squared minus 1 and we factor that out, which is x plus 1 and x minus 1. Okay, then we've got our x plus 1, which is also x plus 1. And we've got our x minus 1, which is also x minus 1. So our LCD then is x plus 1 and x minus 1. Okay, so now we're going to take each of these, factors, and we're going to go ahead and write them with our common denominator. Okay, so we take our first one of 10x plus 8 over x plus 1, x minus 1. So this one already had our common denominator. We don't have to change anything. It just remains as it is. So let's look at our second one, x over x plus 1. We're missing x minus 1, so we're going to multiply by x minus 1, giving us x times x minus 1 over x plus 1, x minus 1. Okay, and then our last one of 3 over x minus 1 times x plus 1 over x plus 1, which gives me 3 times x plus 1 over x plus 1, x minus 1. Okay, so we've got our three terms here. we've got 10x plus 8 over x plus 1, x minus 1, plus x times x minus 1 over x plus 1, x minus 1, plus 3 times x plus 1 over x plus 1, x minus 1. Okay, so now that we've got our new fractions written over our common denominator, excuse me, my throat's a little scratchy here. Now we're going to do some FOILing or some multiplying to get rid of get rid of some of these I apologize. First, we're going to combine over one LCD. So we've got 10x plus 8 plus x times x minus 1 plus 3 times x plus 1. And we've got all of this over x plus 1 and x minus 1. Okay, so we've got all this combined over one. Let me move this up here. We've got all this combined over our common denominator of x plus 1, x minus 1. Okay, now we're going to go ahead and multiply to get rid of these parentheses here. Okay, so I go, I've got 10x plus 8 plus, and I've got x times x, which is x squared, and then x times negative 1, which is a negative x. And then I've got plus 3x plus 3. Okay? And of course, all over our denominator of x plus 1, x minus 1. Okay, so now we get to this point where we've gotten rid of our parentheses on our numerator. Okay, it's all combined over our common denominator. Now we combine our like terms. Okay, so we've got 10x. First of all, we've got x squared, so let's write that first because that's our highest exponent. Then we've got 10x minus 1x plus 3x. Okay, 10x minus 1x plus 3x equals a positive 12x. Okay, then we've got 8 plus 3, which is 11. Okay, over our common denominator of x plus 1 and x minus 1. Okay, so let's walk this back here. See what we got. We had our first three fractions. We found our LCD. We multiplied each fraction to get our LCD. And then we had our new fractions here written with our new common denominator. And then we combined them over our common denominator. So we just had one denominator. Once we combine them over one denominator, then we can combine our like terms, okay, which is what we do here. And now look at this. We've got a brand new trinomial, okay? Now this trinomial can be factored. So now we're going to factor this as x plus 1 times x plus 11. Okay, so we factor this numerator here, and this is where our canceling is going to come. Our canceling of common factors comes into play right here. Okay, so we can obviously see we have a common factor of x plus 1. So we cancel that common factor out. And then we set that common factor to equal 0. So x plus 1 equals 0. So x minus 1 is our excluded value. So our answer then is x plus 11 over x minus 1, where x does not equal negative 1. Okay, so here is our answer. So we're basically combining these two processes of adding and subtracting and finding our least common denominator to solve these problems. There's a lot of steps here, but they're not complicated. They're very basic. Okay, so let's go back to our steps if we get lost and find out where we are, okay? So let's walk through this one more time so we get a good grasp. We had our original equation, or fractions here, okay? We factored our denominators to find our LCD, okay? Once we found our LCD, then we created our new fractions over our LCDs. We had this one, which didn't change because it already had the LCD, this one, and this one. So what we did was we rewrote them, okay, like we had them here, we rewrote them as our new fractions over our common denominators, okay? So once you get to this step and you have your new fractions with your common denominators, then you combine them all over your common denominator, okay, which is what we did here, okay? After this step, then we have to get rid of these parentheses, so we multiply to find our new numerator here, okay? And once we get rid of our parentheses, we can then combine our like terms. And after we combine our like terms, if we end up with a trinomial like this, and it can be factored, then we factor it out and cancel our like terms. And whatever is left over is our answer, including our excluded value, okay? Which in this case was -1. All right. Now, there's a lot there, so let's go ahead and try another one. Okay. Let's try 11.7d, okay, is where we're at. So we've got 5 over x minus 1 plus 3 over 1 minus x. Okay, now looking at this, look at what we have right here. Okay, they look like they're similar, but they're not, are they? We've got a negative here that we have to extract, okay? So we're going to rewrite this, and we talked about this a few lessons ago. If you need a refresher, go back to that lesson. But we're going to rewrite these, extracting that negative. Okay, so now I've got 3 minus x minus 1. Okay, so we extract that negative from here. Okay, remember we can rewrite this as negative x plus 1. So we basically just change the sign and pull that negative out. Okay, so here's where we're at here. Now we can't have this negative like this in our denominator. So what are we going to do? Okay, when factoring out that negative, we're going to rewrite this basically so that the negative is with our 3. Okay, so our 5 over x minus 1 doesn't change. Okay, our plus sign does not change, but we're going to take this negative and we're going to move it up to our numerator. So now we have -3 over x minus 1. Okay, now here, what happens when I did that? I have a common denominator here, so I don't have to go through the process of finding the LCD. Okay, the LCD is already there in these two fractions. I don't need to do anything with that. Okay, so let's review. We've got x minus 1, and then we've got 1 minus x. So in order to extract the negative, we pull that negative out and we change the signs of each inside the parenthesis. Now we don't want to have a negative in our denominator here, so we're going to move that negative up to the numerator. Okay, which gives us a -3 over x minus 1. Okay, so that's how we get this. Now, we have our common denominator, so we can combine 5 plus a -3 over x minus 1. Okay, that gives us 2 over x minus 1. Nothing was canceled, so there's no excluded values, which means that 2 over x minus 1 is my answer. Okay, so that's what we do when we have a negative to extract here. These look like they're the same, but when you write them in the same order, you can see that they're different values. Okay, so we extract this root or extract this negative, and by extracting the negative, that then becomes a common denominator there, and that's how we got that. Okay, so a little bit different of a problem there, but just so you understand how that goes. Let's look at another one. X over x minus 1 plus 2x plus 3. Okay, so in here, excuse me, we've got our x over x plus 1 okay? So we've got x plus 1. And over these, our denominator is going to be 1. Remember that when we have a whole number, we always assume that our denominator there is 1. So our, you know what, I put the wrong sign here, excuse me. Okay, so our LCD then is actually simply x minus 1. Okay, since our denominators are 1 there. Okay, so this one's pretty simple. If it's over 1, then our least common denominator is this right here. Okay, so we have our first term. We're going to have to go ahead and do the same thing here. So we've got this fraction doesn't change. So this is x over x minus 1. And then we've got 2x over 1 times x minus 1. Okay. Okay. And then we do the same thing with the 3 over 1 times x minus 1 over x minus 1, which gives me 3 x minus 1 over x minus 1. Okay, so now I've got my new fractions of x over x minus 1 plus 2x x minus 1 over x minus 1 plus 3 x minus 1 over x minus 1. Now once I get them to this step, then I can just combine them all, or if you'd like to just skip this step and write them all combined under x minus or over x minus 1, that's fine too, but that's totally up to you. So we've got x plus 2x times x minus 1 plus 3 times x minus 1 over x minus 1. All right, so now they're all combined over our numerator. Now we have to get rid of our parentheses. Okay, so I've got x plus 2x times x is 2x squared, negative 2x, and then 3x, and a negative 3 over x minus 1. Okay, so hopefully you guys are still with me here. We've got our terms here. Just make sure I got this right. 2x. Did I do that right? Yeah, 2x. Yeah. Okay, so now I combine my like terms. Okay, so I've got a 2x squared here. I've got an x, and an x. So 3 minus 2 is 1, plus 1 is 2. So I've got plus 2x and my negative 3 over x minus 1. Okay, so now I've combined all my like terms, and now I have this here. Now, my question would be, can I factor this? Okay, is it possible to factor 2x minus or plus 2x minus 3? Okay, and the answer is no. There's no there's no factoring that can take place there. So we can't break that down any further, which means at this point there were no canceled factors, and this cannot be factored any further. So this here is my final answer. Okay, so if you get to here, the next step would typically be to factor. But since we can't factor this won't break down into two binomials. This is as factored as it will get. Then this is my answer with no excluded values. Okay, so you'll see that all of these are just a little bit different. There's just little variations in each one of these. So as you go through here, be very cautious to follow your steps and make sure that you're still going through the same process no matter what it is that you may hit, okay? That is how we do the adding. Now let's look just real quickly at what happens when we have subtracting of these, okay? Now if you remember, the process for subtraction is basically just changing it to addition and then following our addition rules. So let's take a look at some of these. If I've got 4 over x minus 4 minus a negative x over x plus 2. The first thing we're going to do is change the subtraction to addition. And how do we do that? Well, we change the sign and we change this sign. Okay, so both of these signs will change. So my 4 over x minus 4 doesn't change, but this becomes a positive, and this negative would typically go up to here. Now what happens when my numerator is already negative and I'm adding another negative to it? Well, 2 negatives make a positive. So now I've got x, a positive x, over x plus 2. Okay, so because my numerator was already negative and I'm changing that, I'm moving that negative up to the numerator, now I've got 2 negatives, and 2 negatives make a positive. Okay, so a little bit different than we had on the other page. I don't think we hit any with a negative on it, but that's what happens there. So if I've got 2 negatives there, they become a positive with my plus sign there. Now, these become the fractions that I deal with. Okay, so my first step is to find my LCD. Okay, well, this is very basic. These can't be factored anymore, so my LCD is x minus 4 and x plus 2. Okay, that's the combination of the two, since there's no factoring that we can do of these two. Okay, so now, excuse me, I'm going to rewrite my new fraction. So I've got 4 over x minus 4 times what I'm missing, which is x plus 2. X plus 2, so now I've got 4 times x plus 2 over x minus 4 and x plus 2. Okay, so that's my first new one. Then I go x plus 2 times x minus 4 over x minus 4. So now I've got x times x minus 4 over x plus 2 and x minus 4. Now I'm going to rewrite these just like I have them here. So I've got 4x plus 2 over x minus 4 and x plus 2 plus, okay, because we changed this to a positive, plus x times x minus 4 over x minus 4 and x plus 2. Okay, so now here are my two new fractions written over my common denominator. Okay, now I can combine these together. So I've got 4 times x plus 2 plus x times x minus 4 over my common denominator of x minus 4 and x plus 2. Okay, once I've written them over my common denominator, now I need to get rid of my parentheses. So I'm going to go ahead and multiply. So I've got 4 times x, which is 4x, and 4 times 2, which is positive 8, plus x times x, which is x squared, and x times negative 4, which is negative 4x over x minus 4, x plus 2. Okay, so here's my new fraction written over my common denominator. Now I can combine my like terms. So I start with my highest exponent, which is x squared. Then I've got a negative 4 and a positive 4. Okay, negative 4x and a positive 4x. What happens to that? Those cancel out, leaving me with plus 8, okay, over x minus 4, x plus 2. So once we've combined our like terms, my next step is to look at my numerator and say, can this be factored? Okay, can we factor x squared plus 8? Hold on just a moment, please. Sorry about that, guys. I'm having trouble with my throat here. We combined our like terms here, and we get this here. So my next step would be, does this factor? Now, typically we would look at this and say, okay, well, I've got an x squared, I've got an 8. Surely this will factor, but this actually does not factor. So we cannot do anything further with this answer. So this would be my final answer with no excluded values. Okay, now if for some reason that I got a numerator that could factor, I would then factor it further and cancel my like terms, and then that would, whatever's left over would be my answer with my excluded values of the canceled terms there. Okay, but since this cannot be canceled, or it cannot be factored, then there's nothing to cancel, and this becomes my final answer. Okay. P.S. Just a side note, we do not have to FOIL this out for our final answer. Okay. This just remains in the two parentheses there. Okay, we don't have to do anything with that. All right, let's look at one then subtraction problem where we do have canceling. Okay, so let's go ahead and start at the top here. I've got 1 over x plus 3 minus 1 over x minus 3 plus 2x over x squared minus 9. Now, before we do anything, we're going to change the subtraction to addition. Okay, so my 1 over x plus 3 stays the same. This negative is going to be transferred to this 1, and we're going to put a positive in its place. So we've got plus negative 1 over x minus 3 plus 2x over x squared minus 9. Okay, so now these are my new fractions that I'm dealing with. These are no longer relevant to me. Okay, I don't refer back to those for anything. I'm looking solely at these fractions moving forward. Okay, so my next step then would be to find my LCD. Now, if I take x squared minus 9 and I factored this would be x plus 3 and x minus 3. Okay, and then you've got your x plus 3, which is x plus 3, and your x minus 3, which is x minus 3. So my LCD then is x plus 3 times x minus 3. Okay, so I take each one of these fractions here and I apply the same steps to put these over my LCD. So I've got 1 over x plus 3 times x minus 3, which gives me x minus 3 over x plus 3, x minus 3. Okay, so that's 1. Then I take my second one, negative 1 over x minus 3 times x plus 3 over x plus 3, which gives me a negative 1 times x plus 3 over x minus 3 times x plus 3. So that's my second term. And then my third term is, 2x over x plus 3, x minus 3. So this one doesn't change at all because it already has my common denominator. Okay, so let's rewrite these new 3 fractions. We've got x minus 3 over x plus 3, x minus 3, plus negative 1 times x plus 3 over x minus 3, x plus 3, plus 2x over x plus 3, x minus 3. So here are my new fractions over my common denominator. Okay, now we can also rewrite these now so that they're all combined under one denominator. So we have x minus 3 plus negative, which would actually end up being, let's see, do we want to do this now? Negative 1 x plus 3 plus 2x over x plus 3 and x minus 3. Okay, so we combine all of these over our common denominator. Now let me just point this out here. Okay, we have a negative here. Okay, So I put this in a bracket because I want to understand that I'm adding this factor of -1 times x plus 3. Okay, so that's why we put that in a bracket, because we have a negative and we're adding it. So that's how we wrote that. So let's go ahead and get rid of this bracket and parentheses. So let's do this like this. My x minus 3 is going to stay the same. I'm not going to touch that. Okay, but I'm going to multiply -1 times x, which gives me a negative x, and then a -1 times a positive 3, which gives me a -3 plus 2x over our common denominator. Okay, so because I'm dropping the brackets, now I'm looking at this and I've got a negative x, that then takes the place there, and I just write that as its own individual term. Negative x. Dropping the brackets, dropping the parentheses gives me negative x and a -3. Okay, so at this point I'm combining my like terms. Okay, I don't have any x squares, okay, but I do have a bunch of x's, so I've got an x here, negative x, so those cancel out, leaving me with 2x. And then I've got two -3x's, so I've got a -6 over x plus 3, x minus 3. Okay, now, at this point, we would factor, okay? Now, looking at this, we can't factor this into two binomials, but there is a 2 present in both of these factors. So we're going to factor out 2, leaving me with x minus 3 over x plus 3 times x minus 3, okay? And then these then would cancel out. So my answer then is 2 over x plus 3. And then I have to take my excluded value, set it to 0, and solve to include that. So my answer is 2 over x plus 2, where x does not equal 3. And this is my answer. Okay, so the difference here between addition and subtraction is we first, all the way up at the beginning, have to change our subtraction to addition. Okay, and by doing that, we just apply that subtraction sign up to our numerator. Okay, because our numerator is positive, it becomes negative. If our numerator was already negative, it would become positive. Okay, so keep that in mind. Two negatives make a positive. So then I get my new fractions here. Okay, and I find my LCD by factoring them all. Okay, and apply my LCD to each fraction to get my new fractions over my common denominators. Okay, and then we can combine them over one common denominator, and then we have to get rid of our parentheses. Okay, and we do that just simply by multiplying. Okay, and then we combine our like terms, factor, and then set whatever is excluded to 0 and include that in our answer. Okay, so a lot of steps here, but as I said before, the steps themselves are not necessarily complicated so much as they just take some time. Okay, so as you're going through here, don't rush it, slow it down, and make sure you're paying attention to the little details as we go through here. Okay, let's look at our homework for today. All right, there's a lot here on this page, so I'm just going to break it down. We're going to do numbers 1, 11, 22, 25, and 33. Okay, 1, 11, 22, 25, and 33. That's your homework for today, Thursday, May 7th. Okay, numbers 1, 11, 22, 25, and 33. There's some subtraction, some addition, and just follow your steps there. Take it nice and slow, and we shouldn't have too much problems with that. If you come across something, you get a little confused or not sure what's going on, just shoot me a text or give me a call, and we'll work it out together. But this here is our last lesson, guys. So from this point forward, we'll be taking time to study for our final exam. I would like to see if we can get together for a Zoom meeting here before our final exam. I'm going to be in West Virginia this weekend. Should be leaving actually today, but I should still be able to get with you guys, and we can hopefully get together sometime before the final exam. I want to talk through some of the stuff and just answer some questions live together so that we understand what we're getting into before we start the test. And then, as I said, I would like to throw in there some extra credits to help boost your overall grade. So we can try and squeeze that in maybe on Thursday after the final exam. And then I think that from here, that's pretty much it. But as I said, I would like to meet with you guys. So let me know if maybe on I can't do it Monday, maybe Tuesday, or even maybe over the weekend we can get together and just review everything and make sure we're all on the same page for that. Let me know what works out best for you guys. But as for today, 11.7, that's all I have for you. Hopefully that wasn't too complicated. I know there's a lot of steps, a lot of writing going on there, but just take your time, write neatly, go through it step by step, and you always have the video you can come back to and rewatch if you need to. But starting tomorrow, we'll do some review for the final exam, and then take the next couple of days to work on that. The final exam is actually not really that long. I'm surprised there's a lot of material that was left out that I would expect to be on the test. But we'll go over that. I think there's maybe like 25 questions on it or something like that. And I'll include some extra credit for us to do. All right. That's all I have for you. I do want to say one last thing. If for some reason you guys have multiple final exams on Wednesday, let me know, and we're flexible on this so we can move it if we need to move it. I don't want you to have to worry about having other tests on top of algebra. I want you to be able to focus on what we're doing. So if that means we push it up or push it back, we'll do that. But let me know if you have another final scheduled for Wednesday, and we can work around that. Okay, that's it, guys. Have a good day, and hopefully you understood everything, and I'll expect your homework by the end of the day today. All right, guys, have a good day. Talk to you later. Maybe not. Maybe I can't get my computer to work, so you're just going to have to stay with me forever. Just kidding. See you guys later.